Today's video is on moments and generating functions. So the problem here today is prove that the moment generating function of a random variable x defined by the density function f of x is equal to 1 by 3 when x lies between minus 1 and 2 and 0 elsewhere or otherwise is m of t is equal to e power 2t minus e power minus t by 3t when t not equal to 0 and 1 if t is equal to 0. See here, according to the definition of the moment generating function, mx of t is equal to integral minus infinity to plus infinity e power tx f of x dx. Now I have to introduce these limits minus 1 and 2. 0 otherwise. The function value is 0 otherwise. So here this is mx of t is equal to, this is from minus 1 to 2 e power tx f of x dx. So as you know that the f of x value here when x lies between minus 1 and 2 is 1 by 3. Now here, so this will be minus 1 to 2 e power tx, this is 1/3 into dx. So I am bringing this 1 by 3 outside, this is minus 1 to 2, this is e power tx into dx. Now this is 1 by 3. So if I make an integration, that is e power tx, and again for x is equal to 1, t remains between the limits minus 1 and 2. So between the limits minus 1 and 2. So this will be 1 by 3 times of for upper limit. So this will be e power 2t by t minus, and for lower limit this is e power minus t by t. And see here, now the moment generating function when t not equal to 0 here is mx of t is, this is 1 by 3. This is e power 2t minus e power minus t. If I take t as LCM, so this is the condition when t, this is t not equal to 0. And see here, when t is equal to 0, what happens here? So mx of t is equal to 1 by 3 times of e power 2t minus e power minus t by t. And now here, so we have to show that when t not equal to 0, apply when t not equal to 0. Sorry, when t not equal to 0, this is the function value. And when t is equal to 0, what happens? See, then our mx of t is equal to, when t is equal to 0, see here, this will be 1/3. Anything to the power of 0 is 1 minus 1 by 0. So this is 0. So this is 0 by 0. So m of 0, the function value here is 0 by 0. So this is 0 by 0. And when this one, when t is equal to 0, m of 0 is equal to 0 by 0. Now m of 0 is equal to, this is limit t tends to 0. This is t tends to 0, m of t. So this is limit t tends to 0. What is m of t value? That this is 1/3. See here, this is 1/3 e power 2t minus e power minus t by t. Now see here, we have to apply L'Hospital's rule. After applying L'Hospital's rules, as it is 0 by 0, applying, see here, L'Hospital's rule. So now we have to make a derivative in the numerator as well as the denominator, and again we have to apply the limit. So this is 1/3. So what is the derivative of this? That this is 2 into e power 2t, and for this e power minus t, and again this is minus, there is already minus here, so minus of minus plus t, and this is 1 here. So the derivative of t is 1. And now if I apply 0 here, if I apply in place of t as 0, this is 1/3 2 into e power 0 plus e power 0 by 1. So this is 1 by 3. This is 2 plus 1 by 1. As you know that this is 3 by 3. The value here is 1. So when t is equal to 0, see here, when t is equal to 0, so we got 0 by 0. And now we are going to apply the L'Hospital's rule in the numerator as well as the denominator. We have to make a derivative for one time, and again we have to apply t is equal to 0. So 1 is the answer. Therefore, now our moment generating function, that is m of t value is equal to, see here, m of t value is equal to, this is 1/3. This is e power 2t minus e power minus t by t when t not equal to 0, and the value of m of t is 1 when t is equal to 0. See here, this is the function value, and this is what it is asked in the question to prove that. See here, in the question it is also asked to show that m of t is equal to, this is 1 by 3 times of e power 2t minus t by t when t not equal to 0, 1 when t is equal to 0. So this is how we have to write. And see, therefore, the moment generating function is e power 2t minus e power t. If I multiply this, will be 3t when t not equal to 0 and 1 when t is equal to 0. So this is how we have to solve. Thank you so much for watching, and I'll be uploading one more question related to this series. Have a look at those videos, and please go through the playlist and pass it on to your friends, and raise your thumb, subscribe to this channel, and thank you for watching.